Welcome to a fascinating and a highly valuable session which is on module part 2. So, if we just try to locate us, means where we are in this Python course of mine, so we will get to know exactly how can we proceed further. So we have finished with our objects and then expressions which generate objects and then statements which include object and keywords and then a module. Just we have seen the module basics in our previous videos. If you haven't, just please watch the previous videos and jump into this session. And then we are going to look into the higher level, that is the program, in this part of the course. So far in this book I have sugar coated some of the complexity in any descriptions of Python programs. In practice, programs usually involve more than just one file. For all but the simplest scripts, your programs will take the form of multi-file systems. And even if you can get by coding with a single file yourself, you will almost certainly wind up using external files that someone else had already written. So that's what I'm saying. So basically, this section introduces the general architecture of Python programs. This is very important to know because see, from a fundamental blocks, from objects, from root, from scratch we have started. Now slowly we are inching towards the higher level of a Python program. So which is a program? We are moving towards writing an application, a complete whole application, a web application, a machine learning application. So for that you should know the whole ecosystem, how it is structured. So we should know the general architecture of these Python programs. So the way we divide a program into a collection of source files, aka also known as modules, and link the parts into a whole. Along the way, we will explore the central concepts of Python modules and then imports and object attributes. But for now, it is all about Python program architecture. Okay. Obviously, if we want to develop a web application, you must structure your program in a certain way to keep track of all different types of files together. So how do we do that? That's the question. So then the question is how to structure a program. So that's what we are gonna explore here. So generally, a Python program consists of multiple text files containing Python statements. The program is structured as one main, which is a top level file, along with 0 or more supplemental files known as modules in Python, which are known as modules in Python. So let's understand better using an infographic. Okay, in Python, top level eka, also known as script file, contains the main flow of control of your program. This is the file you run to launch your application. And next is our module file. The module files are libraries of tools used to collect components used by the top level file. Top level files use tools defined in module files, and so basically module module use tools defined in other modules. So that's what you can see here. B.py is a module file which uses tools which are defined in another module file that is called a.py. Okay. So now module files generally don't do anything when run directly. Rather, they define tools intended for use in other files. In Python, a file imports a module to gain access to the tools it defines, which are known as attributes. Those are nothing but variables names attached to objects such as functions. So now if you see these modules again, they are importing tools or functions or methods or attributes from standard library modules which are coded in Python itself. These are native to Python. So if you notice the rightmost portion of infograph, some of the modules that our programs import are provided by Python itself. That's what I have told you just before, and are not files you will code. So Python automatically comes with a large collection of utility modules known as the Standard library. This collection roughly consists of 200 modules. This is the latest count, it may vary. So it contains a platform independent support for common programming tasks. So some examples: operating system interfaces, that is OS module, object persistence, text pattern matching, network and internet scripting, graphical user interface construction, and much more. These modules help us to do a lot of tasks. It improves the potentiality of our Python program. So now, so none of the above mentioned tools are part of the Python language itself, but you can use them by importing the appropriate modules on any standard Python installation. So I think you got my point. So you can also be reasonable sure that they will be available and will work probably on most platforms on which you will run Python. So with this, I would like you to take to the a practical world. So where we can see whatever we have seen thus far in this slide. And the first example, so for that what we will do is I will take you into a repository. So where we can have the files that I have set. So now the first thing we'll begin is we'll begin with a simple example, not the difficult one, so that it's very easy to understand. Okay, so we can begin with a simple example. If you see, so I will open this in a VS Code so that it would be very easy to tackle. So I'm opening VS Code in this repository. So now I have opened VS Code. So in this I have one Django blog repo, and below which I have some of the files which are .py and then reviews.csv. It is a data file. So let's begin with the simple one, that's weekday.py. This is the data. Reviews.csv is the reviews that are given to the course. Now I want to use this, I want to do some analytics out of it. So how can I do that? So weekday.py is my main file here. It is my main. So now if you see, import pandas. So one I am importing, import just pi as jp. So each has their own purpose, but that is not our motto here to discuss what is the purpose of pandas, what is the purpose of just pi, what is the purpose of pits. So here I want to show you how do we structure a program. If it is single file, still it will end up importing some other modules written by somebody else. That's what I want to see. I have started, that's what I want to say, that's I have started with a simple example, the very simple example. So these are all visualization projects that I have made. If you see from main file imports, it's importing just by and date time, pandas and pits. So these are all different modules that were written by somebody else. Ultimately, we are importing so that we can access the tools. Tools are nothing but attributes or methods which are written by somebody else as a functions in the module files itself. So now what I will do is I will import all those files in it. Then using pandas, for example, I have taken the read CSV method, and then I am able to communicate with the data set that is there in my repository. So then using just pi using just pi, see this is app, I am defining a app, and then using just pi and some of the tools out of the just pi, I am able to make a web application. So once it is done, so once the web application is created, I'll just execute it and I'll see what is going to get. But I hope you got it. To make a simple file, you need to import a module that were written by somebody else. Once you import the module, then you access the tool set and use the tool set to make your own application. So that's how a Python program works. This is a higher level. We are slowly moving into higher levels. So let's execute this and see what we get. So I got a IP 127 and then 8000, a port where I can expose my application. So let me click this address and we'll see. Yes, fantastic. We got it. We got it. So here, this is a simple web application, a dynamic graph where we have a tooltip, and then on x-axis we have some stuff, and then so this is not our intention to discuss about what kind of application it is. I just want to show you one example. So similarly, sorry, I have to go back to the VS Code. Yes, I'm going back. I came. So now I will take another example. This is a stream graph I have made. Again, we use the same modules. Again, we have used pandas tools to communicate with the external file, and then we have made some data frames, and then we used just pi to create an application, and we used some JavaScript to create a plot, a graph, and then once we created the app, we will call this app at the end. See here, at the end we are just calling this app, and we will see we are able to view it using browser or not. Let me execute this. Sorry, before that I have to close the previous application that have been running. Yes, I have closed it, and now we will enter into the new application and see, hope it works. Yes, absolutely. Let's expose it to the port. It has been exposed to the port, and let's view it. So let me close the existing one here, and let me, yes, fantastic. See how nice it's looking. With the by using some of the modules, you're able to make a beautiful and amazing and fascinating, fantastic graphs, dynamic graphs with the tool tips. And see, this is how you can make. See how nice it is. Brilliant graphs we are able to make. We are able to put out. So I'll close this too, and I'll go back to the Visual Studio Code, and I'll close this web application. I'll stop it. Okay, I stopped it, and then I'll move into another application. This also follows the same, but here what I have done is this is a simple app. So here I have used only two modules. One is JustPy, other one is Matplotlib. And let's see. Yes, let's open. That's it. There is no graph, nothing, but I just want to show you. If you want to add any graphs, then you have to use some JavaScript or something else, whichever you want to incorporate there, you can incorporate. But I just want to show you how a simple web application works here, and how do we structure it. So, and then we have a final one, a simple one, which is the same. It uses the same modules, and we will see what kind of graph we get here. So before that, I'll close the previous app. That's done. Okay, let me run it. Oh, nice. It got executed. Oh, brilliant. So how nice it is. See, with a simple piece of code, you're able to do a lot of work. So that is the power of a module. That is the power of structuring your complete program. So with this, we have seen the simplest way, that means a single main file. But now I want to show you a complete program. See here, if you see, this is a complete one application, a complete program. So it's a little complicated. It will be a little complicated to understand. It's a complicated program, but still I would like you to I would urge you to follow it, because I will make it simple. So I'm going back to the Visual Studio Code. So this is a Django folder. So before that, let me close this Visual Studio Code, and I'll completely enter inside the Django blog repo. So here it is. I'm opening with Visual Studio Code. Yes, I am inside the Django block folder. Let me extend it. Now I hope you're able to see this. Fantastic. So I haven't closed the previous one. Maybe. Okay, let me check. I'll just. Okay, fine. It got closed because I have closed the VS Code. So okay. Yes, it's fine. Okay. So now let me make it simple. So I will run this application. Once I run it efficiently and effectively, then I will show it. I will explain you is how how this has become possible using a Python program structure. Okay. So what I will do now, I am in global, basically in global Python. So I just want to go into virtual environment for that. So I just want to let you know, this is the virtual environment I have created. In that, if I go to scripts, I have this activate.bat. So using this file, i will I will activate a virtual environment. Just give me 1 minute. I will create a virtual environment. Sorry, I will activate a virtual environment. Then I will run this web application, and We will see how it works. Then after that we will discuss about the program structure, how I structure this program. Fantastic. Let's jump in. Okay, so let me enter into the folder of scripts. So where it is, so now we have a directory of this. So scripts, so cd s, now where are we now? It's in Django. Okay, it is inside the env. Okay, we are into the env. So now I have to enter into the scripts. So this is our scripts folder inside that env. So dir capital S tab will get the scripts automatically. Then I will enter inside that. Now we'll see we have different files in it. Mm, Now I want to activate virtual environment. So activate dot bat. Is it spelling is right? Fantastic. I hope so. We are still in base environment. Let me activate this again. Activate dot bat. So using that activate dot bat, we are able to enter into our virtual environment. So this is where we are here, and then it's, you can see, I'll just give python command. So now you can see in that virtual environment I have installed 3.10.2, the latest version python. So let me exit, and then uh, now I'm inside the virtual environment. Now I want to run this complete application. How it is possible? How can we run this application? So to run this application, I have only one file, that is manage.py. Using this file, I am able to run. This is called a high level file. That's okay. I'll run this py manage. Okay, before that, before running this, I'll do two tasks. One is manage.py make migrations. If anything is there, no changes detected, fine. Then I will do manage.py migrate if anything is there. So all migrations are done, nothing, no migrations to apply as of now. So now I will run our application and we'll see what's going to happen. manage.py and run server. This is our sub command. Let us see what's going to happen. Fantastic. We got a similar, see all web applications from the Python environment. It is the port 8000. Let me open it and see. Wow, this is our web application I have written. You can see this is home. You got some blocks in it, and you see some blocks in it, and here it is about page. This is the about page. It is about something, and then I will take you to the admin page. Admin. So this is my admin page. I have already logged into this. This is my okay, and so here I can manually create. So everybody can basically log into this web application. See, for example, I will add, okay, Django app content, this application this tutorial explains how to make web app using Django. Okay, slug, I'll give Django. Author, that's me, dude. And the status, I just want to publish. Now save and add another, save and continue editing, save. So I have added one Django app application. Let's go back to the home page, and let's view site. Let me check. So home, about us, so admin. Okay, so now we have uh, then save. So now, so these are the posts we have in it. Django app, everything, and cats, lines, and all this expose. Okay, so this is our admin interface. So I hope you got uh, it's a typical blogging web application. So I can give access to, see here I have users. I can create access and give password, and I can give access to n number of users to access my application, and they can write blogs in it, and then they can log off. Similarly, I can create groups also. So let's go back to the view site. So once they have created their blogs, and the viewers can view this is the Django app that I have created. So I have created this app, Django app. So this tutorial explains how to make a web app using Django. So that's what I'm saying. Okay, with this I have demonstrated the web application to you. Now, how a single file make everything possible, how this single file has made everything possible. Let's look into that, how it had happened. So now, so this is the Django blog translator is a repository. Inside that we have a different packages. It's either not all of are not packages, but whichever has dot whichever has init file are packages. Okay, before that I just want to make this topic simple. So if you see here, this repository consists of a manage.py. This db.sqlite3 is for a database. It is a database. Okay, now manage.py, this is the main file, the top level file, and I'll open this file. So this main file, so it is importing OS and system. These are standard library modules, but this main file has got connected with the all other packages in it. Blog, env, my site, templates are HTML files. So that is the reason when I use manage.py, and let me close this um, uh, okay, let me close this one. Now I'll show you some pymanage.py help. See, these are the subcommands. You use py and then manage.py, after which if you give change password or create super user, remote stale content, or whatever you want to do, show migrations, and test. If you want to do testing, if you want to test the application, use this test. And if you want to run, use a run server. So though you have created a huge application, there are plenty of folders and subfolders and then modules in it, but you are going to run using a single file that is called manage.py. So that's what I am saying here, main.py. This is a top level file. This will be connected with the other modules and then standard libraries. So that is manage.py. So now if you see the whole project, this is a project, this is a single project. I have created this single project in Django using start admin, Django admin, create a project and then give a name of the project. I gave the project name as my site. So in this project, in this basically, if you see, this my site is a package. Why? This package, basically package consists of a certain number of modules in it. So asgi.py, settings.py, urls.py, whisgy.py, these are all modules inside that package. But how do you say this is a package? What is the difference between a folder and a package? The only difference is if it has trailing double underscore init leading double underscore dot py file. If it has this init file, that means it is a clear cut package, because this init file makes, okay, so because this init file actually makes the difference. So because of this init file, when you call inside that, it understands there are different modules in it. So you don't execute, when you execute those modules, it won't run, it will only provide the tool set. So that's why this init file is given. And if you write anything inside this init file, but you should not write, it will execute automatically. So this is one. So initially we have to create this project. So this init file makes your that folder as a package, so that the manage.py can access the modules inside that my site. Okay, so now asgi.py, so this actually this file is used for the server configuration related to the asgi type servers. And then settings.py, if you see settings.py, this is the settings.py module. This consists of see, it is importing path. So here we have base directory, and then after that we have secret key. Secret key is used when developed on server, deployed on server, deployed on server. And debug is true when you get error in your web application, in spite of showing 404 or some other http errors, it will show python errors. That is the benefit of this. And this is allowed hosts when you go for deployment. This is what you have to use. It takes the host information, and then we have installed application. So now if you want to see, I have, these are all by default admin. We have opened the admin page, and then authorization and everything, these are by default. So this is my blog, this is my blog application that I have inserted into this my site. So if I want to include some other application, so then I have to create one more app, and I have to give the name of that app 2. As I don't have anything, I don't include it. Okay, fantastic. So this is, and middleware helps us in security purpose. And here we have a templates. So basically we have http, sorry, html templates. So those templates I have to give the name of that folder templates, whichever file, whichever folder we have put all the templates. So this is the folder where I have about html, blog, index, base. So that this is the base directory. Base directory is nothing but the repository directory. And then here I have inside that repository directory, I have a templates folder. In that templates folder, I have all html folder. That's what I'm telling here. Then this is whisgy application. Then we have databases. Then authorization and password validation. So then finally these are some settings for the time zone. You can have different time zones and etc. And finally the default auto field. So this is our settings.py, and here this is url.py. So basically if you see in my application, I'll go back to the application homepage. So this, oh, okay, maybe I have closed it, sorry. So I'll run this again, just a minute. Go back to the menus.py, open new terminal. Sorry, this is in base cd. Go to the env cd scripts and then activate dot bat. So no, um, yes, here it is. We got activated. So I'll run py-py run server to run my application. Yes, got opened. 200 which gives a success code. Yes. So now if you see, I have only in my site. This is my site. I have only two. One is home, other one is about us. So home is my application, my blog application. In here it will show the whatever blogs I have written. This is one application, and then other one is about us. So now I have only in my site I have only two URL patterns. One is this. After that directly I will have a slugs. For example, if I give dog, sorry, this is a wrong one, wrong slug. If I give Django, I will get a Django app. If I give line with this is also wrong, I think. Maybe I did not remember those slugs exactly. So that's the reason we are facing issue. Okay, that's fine. So each will have a, okay, these are cats, dogs and lions. Okay, I will give dogs. No, there is something else. The slug is I did not remember that. I have to go back and see. Okay, in the coding. So these are one page and the other one is about us. So we have only two pages. So that is the reason here in URLs in my set I have only two URL patterns. One is blog.urls. So this one, when in home page, whatever, if you directly give the slug, it will take us to blog.urls, that is in another app file, and this is the main admin one. So this one take us to admin. Okay, and whiskey.py is for the different server configuration. This is whiskey is the main Python standard for the communicating between web servers and application, uh, but only supports the synchronous coding. Whereas ASCII, this one ASCII supports the asynchronous Python features also. That is the benefit. We have two types of server configuration here, and then so this is environment. This is a virtual environment. Inside we have uh, different libraries. If you see here, you can find Django. I have installed pip install Django. I have installed Django inside this, and it also have a scripts to run that virtual environment. So that is that environment. So now thus far we have found two packages. One is my site package, and now we are going into another package, that is a blog. So blog is an application in our my site, overall site. So now in my site I can have n number of application. I have created blog application, and I can create a translator app. I can create some calculator. I can create some text to speech converter, PDF to Word converter, image to PDF converter. I can put n number of applications. So as I call this blog folder as a package because it consists of init file. So this makes whatever modules inside it possible to be imported by the other main file or other files. Because of this init file makes everything possible. So admin.py, so this is where we have, using this post class, we are able to create that post using user interface. And this is apps.py. So this is our block configuration, and then models.py. So this is where our actual so whatever block we have created, so using I'll go back and I'll show you the blog. So basically this blog structure is, here you have, okay, we'll do one thing. I will open database SQLite DB browser, and we'll see what is the structure of our model. And open the database which is in, okay, record Python raw, and then modules, structure, program, Django. Here it is. So this is our database. This consists of different number of tables inside that database. So now I want to see, this is my blog post. I will browse this one, a blog post. See, these are the blocks I have. To create this type of model means title, content, slug. See, dogs, slug is dogs. Okay, now I will see. Okay, never mind. It happens. This is programming. Okay, slug. Then we have status, author ID, date created. To create this kind of model, we will use this models.py module. See, you see, I have created a class name post. Inside that, I have a super classes, capital MODL. This is the superclass model. And then title, content, date, slug, author. These are the 6 columns I want. So these 6 I have defined it. For that we use. And now this one will communicate with our database. Whatever we store it here, it will give it to database. And whenever we call it, it will show it in our user interface. That is the models.py. And we have a test.py. In test.py, it is basically used to test your application in production or before production. So you can write some test cases here. You write your test cases here and then test it. And this is url.py. So this urls.py is to give the patterns for the blocks. Means, see, I was telling now. See, if you use about slug, it will take it to the about page. And if this is the case, it will be in home. If there is nothing mentioned here, this is in home page. If you give admin /, it will take to admin. So this is specific to that blog only, specific to that application. These URLs are only specific to that application. For example, if you have created one more application, so that would come here with the application name. Inside that you will have a one more urls.py. So there you have to give the pattern how that application, whatever items, whatever templates inside that application or whatever pages inside that application should communicate with each other. So this is the URLs pattern of application. This urls.py in my set is to communicate with the other each application, to bring each application into your main my site. So that is the difference between this. And finally views.py. So this is what makes everything visible. So whatever you have written in models.py, that is a table. Now this content, if you want to view it, you should connect it with the HTML file. So that's what we are doing here. Model, from where we got it, from post. What you are doing, you are actually importing. See, if you see, from dot models means, from the dot means, in this repository you have a uh, models module. From that you import class post. So that is the benefit. So now you import that post and you make it model is equals post, then the template name is blog HTML and you view it. So this is how we are interconnecting the modules to other modules. Okay. So finally, even if you take another example, if I take urls.py, basically what it is doing, it is, if you see, from django.urls path include, this is importing modules from the Django itself. Now if you see models.py, in models.py, see, it has imported from models. There is a module of models and from that it is importing. And URLs, if you see here, the top one, from dot means, in this folder import views. So views is this views.py. Views.py is the module and the name of that module is views. So that's why we are calling it as a views. So using that, you are connecting with the URL pattern. So that what we are doing is, we are connecting a SQL or our SQLite database with the user interface, that is HTML template, using views, and to call that you need a URL. So that's what we are mentioning here. So finally, to conclude this application and how to structure a program to create this kind of application, I would like to tell you that so you will have a manage.py file, that's the main file, and you will have a sub modules. So basically, if it is a if it is a bigger application, so what we will do is, we will write a package. So blog is one package, my site is in another package. So how do you notice that this is a package? It should have init file, then only it can work as a package, then only you can access modules from it. So then once you get the modules, basically these modules get tools from standard libraries also. So now to execute this whole program, to run this whole program, which file is required? Only one file is required, main.py. Main.py and manage.py in our application. So with using one main file, which is the top level file, we are able to run an application. So that is the power of a structuring a program properly. I hope you got it right. So now we will see what else is left in this slide. So you can see the whole program is working absolutely fine. So now standard library modules, we will look into it. So Python automatically comes with a large collection of utility modules known as the standard library. This collection is roughly 200 modules large at latest count. Okay, we will while we are in Jupyter Notebook, we'll see how to get these modules. Okay, now, so now we thus far it's brilliant. We have covered almost top level or high level concepts of Python. Congrats! We got uh, we got to know how to structure a program, a big application. We have been using the keyword or import statement frequently. Of course, we have discussed about the same in different scenarios in previous videos also. If you haven't watched those videos, I am urging you, I am requesting you to watch those videos and then come here. Okay, then your learning will be seamless. It will be an incessant flow. So, but now we will explore about the import statement in depth. Enough of waiting. Let us deep dive into it. So, in Python, imports are not just a textual insertions of one file into another. They are really runtime operations that perform three distinct steps. The first time a program imports a given file, note down it import runs a runtime operations that perform three distinct steps when you first import a program or a module. Got it? So the first one is find it. First, Python must locate the module. First, locate the module file referenced by an import statement. So notice that import statement in the prior section's example names the file without a .py suffix and without its directory path. It just says import some module name instead of something like import and then give directory name and then Python full file name. So in fact you can only list a simple name. Path and suffix details are omitted on purpose, and Python uses a standard module search path to locate the module file corresponding to an import statement. Now, because this is the main part of the import operation that Pythonians must know about, so we will return to the Python module search path in a moment. So meanwhile, we will move on to second step in importing a module. That is compile it. Basically, compiling is a subjective in Python. I'll tell you why it is. After after finding a source code file that matches an import statement by traversing the module search path, Python next compiles it to bytecode if necessary. Note this point: if necessary, then only it compiles it to the bytecode, source to bytecode. That's why I said this is subjective. Okay, then Python checks the file timestamps, and if the bytecode file is older than the source file, in this case it automatically regenerates the bytecode when the program is run. On the other hand, it finds a .pyc. It is Python compiler code extension. Bytecode file that is not older than the corresponding .py source file. It skips the source to bytecode compile step. So that's why I told you compiling process while in import steps is a subjective in nature. Okay, then the third step is run it. The final step of an import operation executes the bytecode of the module. All statements in the file are executed in turn from top to bottom. This we have known, and this we have discussed in module 3, the statements and syntaxes. Okay, just go back and visit that video too. Now, and any assignments made to names during this step generate attributes of the resulting module object. So in this execution step, therefore, it generates all the tools that module's code defines. For instance, diff statements in a file are run at import time to create functions and assign attributes within the module to those functions. The functions can then be called later in the programming by the file's importers. So now, as you can see, import operations involve a bit work. They search for files, possibly run a compiler and run Python code. Because of this, any given module is imported only once per process by default. Future imports skip all 3 import steps, and reuse the already loaded modules in memory. If you need to import a file again after it has already been loaded, you have to force the issue with an import.reload. Call a tool. We'll meet this in next chapter. Don't worry. But I'm just telling you the overall gist of it. So now we will be entering into the most exciting and fascinating stuff for a Pythoneer. So as I mentioned earlier, the part of the import procedure that is most import to Pythoneers is usually the first locating the file to be imported. That's the first step, the find it step. Because if you, because you may need to tell Python where to look to find files to import. So you need to know how to tap into its search path in order to extend it. I just like to give one example, a simple example. Just don't take it seriously. Yeah? So somebody has stolen something from your home. So now immediately what you'll do, you'll go to the police station, nearby cybercrime police station, and you'll visit the police station, and then you'll file a complaint. So once you file a complaint, so then the action starts. Now what happens? The police, whoever is there, the police takes the input from you, and he will start his process searching. So how will you search? He will have some records. He will have some 3 to 4 records or 5 records. So okay, these much of thieves are there we have, and maybe this thief can be in this place. They have the pre-existing records, and based on that records, this police visits those existing or old thieves. He will go to the thieves, and then he will speak to the thief, and he'll ask him if you have stolen or not. It's some kind of interrogation. If that is the guy, then he will bring that guy. So he's bringing that module. He will bring that module. Then he will compile it. Compiling is nothing but he will give left and right. He will beat him to the shit. Then once it is done, then he will give back to you whatever he has stolen. The same way here also works. So now the first step is searching. finding. So the police has the pre-existing records to search. But here also we have some pre-existing records, some pre-existing paths, some pre-existing ways to find a module. So we will look into that. This is what we call in Python as a module search path. Okay. So in many cases, you rely on the automatic nature of the module import search path and won't need to configure this path at all. Okay. However, if you want to customize the Python search path, you must know how the search path works. So that is the reason we are here. I am here to explain it to you. So the first one, roughly Python's module search path is composed of the concatenation of these major components, some of which are preset for you, and some of which you can tailor to tell Python where to look. Okay, so now the first one is the home directory of the program, means whichever wherever location your all the files are located and from where your interpreter is presently running. And second, the Python path directories. This can be customized. This can be, of course, the home directory of the program also can be customized. We can add there. And then Python path. And second one is standard library directors. We cannot do anything with that. This is standard. And then the fourth one, the contents of any .pth files. We can actually write a .pth file and we can include inside the Python, and Python can execute that file, and then it will go there and it will search that. So these are the first and third elements of the search path are defined automatically because Python searches the concatenation of these components from first to last. Though the second and fourth elements can be used to extend the path to include our own source code directly. So now here is how Python uses each of these path components. The first one is home directory. Home directory, Python first looks for the imported files in the home directory. So the meaning of this depends on how you are running the code. When you are running a program, this entry is the directory of containing your program's top level script. Okay. And when you are working interactively in command prompt or Python shell, this entry is the directory in which you are working. That is the current working directory. Now, because the home directory is searched first, its files will also override modules of the same directories elsewhere on the path. I hope you got the point. Let me show you how this actually works. Okay, first one is I will open the Visual Studio Code because so this is my project. Okay, now if I'll just open a new terminal, a different one. Now this is my home directory. When I am working in this repository, the Django blog, this is my working directory. If I use this, or if I use some command prompt, then this is my present working directory or home directory of the programs file. So the Python first looks there, it looks there, first it looks there. Then we have Python path directory. So next, Python searches all directories listed in your Python environment variable setting from left to right, assuming if you have set already. You don't need to worry. So I will explain, I will show it to you how to set a Python path environment variable. So before that, I would like to tell you that Python path is simply set to a list of user defined and platform specific names of directories that contain Python code files, basically Python modules. You can add all the directories from which you wish to be able to import, and Python will extend the module search path to include all the directories of your Python path. So basically now I will show you how to, okay, or else we'll do one thing. So we will discuss while we work on Jupyter notebook. In that case, I will explain how to set the Python path environment variable. For now, we will move on to the third stage of module search path. Okay, that is the standard library directory. So next, Python automatically searches the directories where the standard library modules are installed on your machine, because there are, because these are always be searched. They normally do not need to be added to your Python path or included in path files. So now we will move on to the last stage of module search path, that is .pth path file directories. So here, finally, a lesser used feature of Python allows user to add directories to the module search path by simply listing them one per line in a text file whose name ends with .pth extension. Okay. Now these path configuration files are somewhat advanced installation related feature. Of course, we won't cover them fully because it would be overkill for this a simple course. Okay. So now, so what we will do is I will just show you how to get the standard library directories. Okay, now we will jump into the Jupyter notebook, and we will see the same steps, how the module search path searches and gets back the module file after searching through all these directories. If it doesn't find, it will throw an error. It will throw an error saying this name is not available. So now I am in Jupyter notebook. Let's begin with the first stage of module search path, that is home directory. So home directory is location where my project files or top level script is located, such as main.py or manage.py. In case of manage.py, in case of our Django blog app. And then so here is, in this case, my home directory is this. I have shown it to you earlier. So just to cross check, let us use OS library, which allows us to interfere with our operating system. So these are some of the classes and then modules that belongs to that modules and classes, and then methods that belongs to that library. So what I have done is, this is a standard library. I have imported that So that means this has gone into the standard library directory. First, it have searched. It might have searched in our home directory, then Python path, and then finally it has gone into standard library. From there, it has fetched that OS library or module, and then from there we are able to use tools inside that module. One of it is get CWD, and I'm able to get the current working directory. Now, just to check where we are in, list the directory. So, in our home directory, we have three modules. I'll show you. So, this is our home directory. This is our home directory. How import work? So, these are the three modules I have written. I'll just open Visual Studio Code here also. See, module 1, module 2, module 3. Module 3 consists of list, fetch list, two methods. Module 2 consists of table powers. Module 3 consists of make, upper, and repeat. These are the three methods. So these two methods, here two methods, here two methods. So now here, so let us import module 1 and work on the module 1. So as now basically I am inside the same folder because I have opened Jupyter notebook from that folder only. See here, see a root folder, it consists of module 1, module 2, module 3 in that folder. So let's see whether we are able to access those modules or not. So you see the directory of module, I have make, upper, name, repeat, type, total 4 methods inside it. So I just want to access one of the attribute. So mod 1, what is the name of module? It is module 11 test, and mod 1 type. What is the type? Basically that module is text based, textual based strings type module. So now we will use one of the method from the module 1. So module 1 consists of make, upper. This is module 3. See, module 1 consists of make, upper. I want to use this method. So make, upper, Krishna I gave. Let's see whether will it make upper or not. See, Krishna has become uppercase. So that's how we are able to access the namespace of that module. So with this we are able to demonstrate that the first stage of module search path is your home directory. If your module file is in your home directory, then automatically you can easily fetch it. There is no issue at all. Similarly, I have done with the module 2. It consists of again name, powers, and then table. So let's use table. This is for the multiplication. I have used table method of module 2 and executed. So it's working. Fantastic. It's brilliantly working. Now we will move on to second stage of module search path. So this is basically in Python path directories, it will search. The first stage is home directory. Once it is done, it will move on to Python path directories. So now let us set up a Python path directories to import modules from our own directories. So what we will do is, first we will go to the Python path or environment variables, and we will check whether by default any Python path directory is set or not. If it is not set, then we will set using two different methods. One is through command prompt, other one is using graphical user interface. So then we will try out one module by importing one module. Let us see whether it works or not. Okay. So now basically before we are setting up, we will check now. Okay. So for that what we have to do is we have to for Windows, window plus R. So then type in run, type sysdm.cpl. Then it opens a system properties window. So here go to the advanced tab and just come down right below the window. Right below the window you can see the environment variable. Click on this environment variable, then it opens environment variables window. In this window you can see here, this is chocolate tea last path update. There are different variables will be there. So one drive and this path, basically path variable, path variable is for the role of this is a system shell search path for finding python.exe. And this is another variable is PyCharm community edition environment variable, and for us the most important one is Python path. So by default I have one variable set. So basically Python path variable is used to it is used to search for the module. This gives you Python module search path for imports. Now let's see any other temp and tmp. These are not important for us. And sometimes you may find Python startup. All are capitals like Python path, Python startup environment variable. This path is used. This path is used to Python interactive startup file. Okay. Next, we can also have TCL library. This is for the graphical user interface extension variable such as tkinter. So, but for now, Python path is important. So, what I will do, I have this. I have this Python path set by default. So, I want to delete this. So, now I do not have any Python path environmental variable. So now environment variable. Now what I will do, I will close it and I will check whether I am able to import one module which is in my another directory from command prompt. Let's see. So everything is set. See, my modules are here somewhere. Okay. So these three modules, mod 1, mod 2, mod 3. Now I will open command prompt. Okay, exit, then cls. So now I have opened my command prompt from this location. So now I will try to import mod 1. What is the error? What is the error? It has been thrown module not found error. No module named mod 1. So we are unable to import module from the command prompt because this is at a different location. So normally what is that? What it does? So when you call for import, it will check for the home directory of the program. So my home directory is C. So in that I do not have module. Then it will check for the Python path directory. Python path directory just now I have deleted, so nothing is there. Then it will go for the standard library directory. In standard library directory it won't be there because this module is created by me. So now finally it goes to the contents of any .pth files. I have not included anything such. So finally what it has done, it has thrown an error simply. So that is the reason after searching through this path it has thrown an error. So now what I will do, I will set up an environment variable Python path through command prompt first, and let's check where will and I will import from the same location. See this C user Surya, from that location only I will import. Let's see will it work or not. I will exit now, and then I have to set Python path variable equals to the location I have to get it. The directory is here. Let me give it and execute it. So I got it. Now import py import mod 1. Fantastic. It's working. You see, import mod 1, and let me check what is there inside the mod 1. It consists of name, repeat, type, make, upper. I'll show you what is that also. So mod 1 URLs mod 1. See, this is our mod 1 in that folder. So it consists of upper, make upper, repeat, and name type. So let me access one of the attribute from it. Attribute is name. So it is module test 1, and so similarly I have some other modules in that directory. Let me import other module also. That is module 2. Yes, we are able to import module 2. So let me check what is there in module 2. So it consists of name, type, powers, table, and etc. Similarly, let me import module 3. It has module 3 also. Yes, we are able to import module 3, and we will check what is there inside the module 3. So it consists of multiplication list, fetch list. Okay, it is about the list. Okay, we will do some module 3, and then mod 3 and name. So it is a module 3. What is the module 3 type? Module 3 type is list based. So this is how using command prompt you can actually set up an environment variable such as Python path, and you can customize your Python module search directories. So now what we will do is we will use graphical user interface to add your another directory to the Python path. So now what I will do, so I will again use window plus R and sysdm.cpl and click OK. Then system properties windows opens, and then go to the advanced and move down to the bottommost and find out the environment variable soft button and click on that. Once you open, you can see the two boxes in the environment variables window. In environment variables you have user variables, that is those are only you can change, and you should never mess with the system variables. Okay, so now what I'll do, uh, I will add Python path, and then I will copy another. This time I will give another directory. So this directory is in D. Sorry. This directory is in desktop. This is on desktop. So let me copy it and paste it. So okay. So my Python path variable has been set. So let me say okay, and again let me say okay. Yes. So now we'll open command prompt and py, and let me check what is there in that folder. It is uh, I think it's test module.py, the name of that. So import test mod. Yes, done. Okay. Now let me check what is there in that test mod. So it consists of name and type, only two attributes, and info, a method. So first we will give test mode dot type, and we'll see it is text based, and then info method, and we'll see what is there in it. You are able to access this module using Python path customization through graphical user interface. Okay, so this is done. So with this we are able to add our custom directories where our modules present in the Python path variable. Okay, now what we will do is we will again enter move to the environment variable windows, environment variable window. Now I will show you how to add multiple Python path variables. Edit. So now here basically you can add one more. You can keep on adding how many you want. So like this it comes, and then you can keep on adding how many Python path variables you want. This is how you can actually customize your Python path variables, and you can add your custom directories for the module import. So this second stage of Python module search has been done. Then we will move on to standard library directory. So here this is as usual. It is not a rocket science to discuss. It's very simple. So basically this standard library directory, we have some set of standard libraries that we have discussed earlier. So now we will try to find out the path of that. Okay, so for that what we have to use is sys a system module, and then path, sys.path. You will get it. So what I have done, these are the default Python default system libraries. This the initial one basically, which comes as it is our home directory. So that's the reason this one has come, because my Jupyter notebook has opened in this directory. So that's the reason that is present. So now what else we can do with is, so this is my present home directory. That is the reason we got this. Next, in addition to that, let me execute this again. Okay. So now there's a standard library directories. I just copied here, and these are some built-in modules: math, NT, sys, time, cmath. This is the way to find out those built-in modules, and this is like bonus code for you. I just included so that you will be aware of that. And so these are some built-in namespace. These are some built-in namespace. See, type, var, zip, string, sum. Of course, plenty of them are objects, but when you give built-ins, you will get the built-in namespace. Then finally, we are moving into a fourth stage of Python module path search. So here, what we'll do is, this is a little advanced topic. I'll just touch the basics of it, and then you can learn more if you want. I'll provide some resources of it. So the contents of any .pth file, for example, the following is the one .pth file in which I have written the directory names where my modules open Visual Studio Code, and then see the contents. Let me go to that folder where it is, yes, here it is. So as.pth. So this is the .pth file. Inside that I have included one directory where I want Python to look for the module and import it. So I can add one more, I can add one more, I can add more. So that's how a .pth file works, and that's how we do. Now what we'll do is, so we have actually completed with the stages of Python module search path. So finally, now we will discuss how we can change the module search path. So Python program itself can actually change the search path by changing a built-in list called sys.path. That's what sys.path. The path attribute in the built-in sys module. Sys.path is initialized on startup, but thereafter you can delete, append, and reset its components however you like. So import sys, and I'm storing the path library director, all module directories as a list into X. Okay, so now X is my list. Now what I will do, I can use list methods and then append whatever item I want. So now what I will do, I will insert in 0 positional index. What I will do, I will insert one. So which one I will insert? Module testing. This one I haven't used, so I will use this link, this library. Sorry, this directory. Now I will use this directory. See, okay, let me execute it. See, D module testing command. That's where my. So now I have included this the directory where my module files are there in the system path. So from there, so basically I can, oh just a minute. See, I'm able to import from there. That's how we can change or include some of the directories, some of the custom directories inside the path list, so that we can customize our module search path. So with this, we reached to the end of a long part of the module 5. I hope you enjoyed it, but this is too much to grasp. But this is very advanced topic. Please note it down. Please write a notes. It will be very helpful, because it took almost plenty of days to find out all the information, because you won't get it directly. You won't get it. Okay, it took a lot of pain and lot of resources, lot of time. So please use it properly. Please spread it to everybody so that everybody can benefit. I'm not expecting anything from you. I'm expecting only one thing, that get knowledge and share this knowledge. And with this, thank you, and I will see you on another session. Keep subscribing it, keep liking it, and keep watching it. Thank you.